Okay, welcome back. So the next part of this workshop is the operations in practice, presented by Robert. So let's welcome Robert.
Hello, can you let me share my screen?
Sorry, can you not, are you not allowed to share?
Trying.
Yeah, okay, so yeah,
Okay.
it's all good.
Okay, cool. Okay, hi everyone. My name is Robert. Okay, I'm a senior pricing analyst in IAG. And first of all, I want to give my thanks to the organizer, to AWS and Daniel Frank. And then in the next hour, I'm gonna give you a quick demo of how to approach Kaggle Project 1. Okay, so first of all, we need these packages. Data locable is the main data manipulation. Two most popular packages. The other one is dplyr, part of tidyverse. And ggplot2 is for plot visualization. It was inspired by Photoshop, like layer upon layer plotting. And stringr is a nice wrapper for string I. It's for string manipulation. And lubricate gives you a neater code to handle datetime data. And I just use weighted quantiles function in this package and nothing else. And H2O is the main machine learning package. It's a Java-based machine learning package. Okay. Okay, first of all, we need to define some functions. It's a good practice to do some modularization. Like once defined, we can apply it many times. So the first function is NA columns. So the idea is that it's checking column by column and see whether that column has NA values. If yes, print that column name. Okay, and the next function is called a probe. So basically it's a function, it's a shorthand of ggplot2. It returns a bar chart if the variable is a categorical. It returns a histogram if the variable is numerical. Next one is one way. It's also based on ggplot. So basically, it superimposes variable distribution average response per each variable level. As you can see, this step is drawing the histogram of the variable or the distribution of variable if the distribution is categorical. And then this step is drawing the average response per each level of the variable. Okay. Now we go to the exploratory analysis. First of all, we need to load the data. Let's have a look at the date range of the training dataset and test dataset. So basically, we're using the past data to predict future performance. Okay. And then let's have a look at the column names. The training dataset has this number of columns. And the store dataset has this information. And they share the same column name store. So potentially, we can merge them together using storm as merge key. So this is the merging code. Yeah. And after merging, we check the data size. So this data set is really, really big. It has 1 million rows. But for this demo, I can't run this 1 million rows. Otherwise, it will run forever. So I just take a small subset of this big data set by the sample, by this function sample. Okay. Although it's random, but for better replicability, I mean, in the working environment, sometimes you will have peer review of what you have done. So it's better to have something that is replicable So it's the best practice to set a random seed. In this example, just set random seed equals 100. And then we have 1,115 different stores. Then we just randomly select 10 out of the 1,000 stores. Okay, after that, we check the dimension. See the big drop, right? Because we're only using 10 stores. That's an illustration. Okay, so we move on to understand data. Step 1 is to check whether there are NA values. Okay, it tells you that these 4 columns have NA values. Okay. This is just explaining the logic. It's not very mature. That's good. And step 2 is to check the factor distribution. So when I say factors, I mean rating factors excluding response. And I just treat sales as the response. I'm not planning to build a model based on customer number and average sales, but it's a good idea to try. And also, I'm not building separate models for each individual store, but you can try. So we have 1,115 stores, but it's not a problem if we can automate the process. Yeah. And then these are the factors, excluding the response. So in total, we have 17 factors. Okay, then we can use the modularized function probe to check the distribution. The first one is the store, because we're only sampling 10 stores. So it makes sense that we only have 10 levels. Right. And to help you understand this graph, so for store 1031, we have 942 rows for that store. And we have 750 rows for store 1004.
Excuse me.
Yeah.
I think everything is going great so far. Just some of students say it going a bit too fast and they can't really follow.
Sorry. Let me check the.
Okay.
Where is the comments? Yes. Okay.
Okay. So if you can maybe
sorry.
down a little bit, yeah.
Okay.
And maybe you can check the group chat like Danny before. Okay.
So which part you guys don't understand? I can explain further. Okay. Maybe I just go on with more explanation. A section before I. Okay. These are the modularized functions. I think you'll understand this better with correct context. I will definitely use these functions in later sections. So if you don't understand these functions for now, don't worry. Actually, it's okay. Maybe I can, yeah, because I have already used this function. Maybe I can explain this a little bit in more detail. Okay. So NA columns. Okay, NA columns. So I'm using this data set train_sub as the input of the function, and what the function does is like so send how it is. Oh, sorry. So this function is defined as for each column in this data set, I just check if there are NA values in the column. Okay, so let me give you some example. Okay, for example, this one. So this one is checking the column promo to since week. And basically it's extracting rows where the variable is NA, where promo to since week is NA. Check. So see these values are all NA, right? Then if we check the number of rows, 4,342, which matches this number. So if you type .n, it gives you the number of rows of the selected data set. Okay. And let's check an example of a column with no NA. So if you run this step, it says empty data.table. We ask for the number of rows for this subset, so 0. So that's why we can use this syntax. This syntax here, to identify whether there are NAs in the column. I guess it's clear, right? Okay, so someone may notice that I use the get bracket column instead of the column name. To understand get function is it's very easy. Like if I define A as 1, and then this syntax is equivalent to if I write assign string A, comma 1. Yeah. So these are equivalent. Well, get function and set function are very useful when you are writing loops. Especially when the variable name changes. Yeah. Okay. So factor distribution. Okay. Just to check that we have 17 factors. These factors excluding sales. And then let's check one by one. So this one we have already checked. Let's check day of week. So we have 7 levels from 1 to 7. Makes sense, right? Because we have 7 days in a week. And if we draw a bar chart, looks like this. So we have slightly more rows for Thursday and Friday on the calendar. I guess it's normal, right? So the next one is day. This is too granular. Basically, we're counting the number of rows for each day. Okay. It seems that we have 10 rows for each day. But is that really true? We can check by running this line. So this gives you all the values in column n. And if we do a unique function, we know that we have 2 levels, like 10 and 6. If you're not very comfortable with data table syntax, you can try base R syntax. It's very similar. Yeah. Okay. The next one is customer. Okay. So this variable, first of all, is numeric. And then, well, for numerical variables, we typically use a histogram instead of bar chart because there are too many levels. And if we look at the histogram, there are a few things I want you to pay attention to. First thing is that we have a very long 0 bar here. And this is something that you should be worried. You should ask yourself, what causes 0 customers? Is it related to something else? Or is it a purely random process? And then secondly, we have this double P. Okay. And then lastly, we have a very long tail. In practice, we don't want to just put this variable as it is into the model because this long tail will keep some overfitting. We'll probably cut it here or maybe here. Yeah, here, maybe better. Here. Okay, the next one is open. It's a Boolean variable, meaning 0 and 1. Okay, see the graph? It looks like this. So 82% of the time, the stores are open. Okay. The next one is promo. It's also a Boolean value. It's very similar. I will cover it in too much detail. And then state holiday. This one is a categorical, although 0 means no holiday. Meaning it's not a state holiday. And then A, B, C is just 3 types of state holidays. But you should ask yourself, what is A and B and C? In your work, if you don't understand the meaning of the variable, ask your manager. Ask. Okay. If we draw the bar chart, it looks like this. So the majority is not state holiday. Makes sense, right? We don't have holidays every day. Yeah. Next one is school holiday. It's a Boolean variable. And we have school holiday for 17% of the time. Okay. The next one is the store type. It's related to store, actually. Okay. Because I just a subset or sample 10 stores instead of the entire 1,115 stores. So I have levels A, C, D. Then you probably should ask yourself, is there a level B, like A, B, C, D? That makes sense, right? So again, ask your manager. Yeah. Okay. Then assortment. Very similar. Competition distance. So it's a numeric variable. Okay. So we draw a histogram. It looks like this. Well, because we're only using data for 10 stores, so this histogram may not be very useful. We should probably look at the entire data set. So will make more sense. I thought it would take a while to run. This is okay. Yeah. Yeah. So the warning message, non-finite values, actually means NA. To confirm this, remember we have 2,642 rows, right? Then this, checking if it is NA, we have this same number of rows NA. Okay, because we have so little observation, drawing a histogram may not be very useful. We can draw a bar chart instead. Just treat it as a categorical button already. Okay, the next one is competition open since month. Okay, so if you use this, if you use data.table syntax, like this is the next .n. Returning the number of rows by a variable, the variable name here. You have this. You have an NA value here. And then if you use base R syntax, it gives you this. So this is something you should be warned. Bear in mind that if you're using base R syntax and use table function, it will not give you NA level. Okay. So the non-missing rate is 52%. These are some checks. Okay. So this is the bar chart. Okay. Next one is competition open since year. Okay. So we're doing the same. As you can see, the base star syntax cannot capture the name value. Okay. So not missing rate, and bar chart. Yeah. Promo 2, excluding variable. Okay, so we have both promo and promo 2. So you probably need to figure out what's the difference between promo and promo 2. So you can run something like this, but it doesn't give you too much information. Like, for example, when promo equals 1, we have both promo 2 equals 0 and then promo 2 equals 1, and it seems that it doesn't have any pattern. Again, if you don't understand the meaning of the variable, ask your manager. Sometimes a story is very, very important. Yeah, you need to somehow back your model with a plausible story. Yeah. The next one is promo 2. Thank you. Since week. Okay. And we have this distribution. Okay, very similar. I won't cover in too much detail. And next one, promo solutions here. Okay. The last one, promo interval. This is something very interesting because the first level is empty. This is what we call the string missing. You know, if you look at the 4 levels, 3 of them are made of combinations of months, but 1 level is string missing. Okay. So if you look at the data, looks like this. I mean, in practice, if you see the majority of the variable is missing or string missing, should be worried actually. It should be worried about whether you should use this variable or not. Because people give too much weight to the default level. Okay. Yeah, there's something very important. You should check NA dependency. So there are 4,342 string missings. Are they related to factor 15 and factor 16? Because if you just look at, if you just look at the names, it seems to be related. So to determine that, you should run this loading test. Like if factor 15 is missing, it is true that all factor 17 is missing. And the other way around, if factor 17 is missing, it is true that all of the factor 15 is missing. You should do this for both factor 15 and factor 16. And if they all pass, then have peace of mind. And you're sure that these variables are related. Okay, we have covered all the factors, namely all these 17 factors, checking the distribution like NAs, any anomalies. And then we also need to check the response distribution. So in this case, response is sales. Okay. Take a look at here. It's a very long 0 bar here. Actually, this one is where is correlated to sorry. So, and if you still remember when we check this variable, also have a 0 bar here. Okay. So these 2 variables are related actually. Okay. So we need to consider 0 and non-zero separately. For zeros, it could be random or determined by other variables. We need to figure it out. I mean, if the 0 sales is random, we can try Tweedy distribution. Tweedy distribution is a widely used distribution assumption in insurance industry, especially for GI insurance. I think it works best for very small portfolio, for example, commercial packages rather than personal line. And if we have enough data, for example, in personal line, we can build separate models for claim count and claim size. But if the portfolio size is very small, maybe it's better to use the entire data set and build one model. When I say one model, I mean model based on claim cost rather than the components. Claim cost equals the product of claim count and claim size. Okay, so if claim count equals 0, claim cost could be 0. And if claim count is bigger than 0, for example, 1 or 2 or 3, and after times the average claim size or actual claim size, it will give you positive claim cost. So this graph, if I was not given the correct context, like this is about daily sales, I would say it's a it's possible from insurance industry, it's possible that it's about claim cost. Okay. So this is the case if the 0 is random, but if 0 is not random, then okay, it's related to some question. We will revisit later. Okay. Okay. So let's first have a look at the non-zero sales. If we remove this bar here, we have this nice shape. So we can assume gamma distribution. Well, sorry, originally I thought the questions will be asked throughout the presentation, so I just write questions here. I guess I will give the answers. I guess I will give the answers myself. Okay, the first question is why not normal? Normal is symmetric, and this one is not. And also normal has a normal tail, but this one has a long tail. And also for gamma distribution, all the values are positive. So we use gamma instead of normal. And other possible assumptions, including log normal. Yeah, you can try that. Yeah. Okay, let's move to the zero sales investigation. So let's try. The first question, is it because of day of week? Okay, so this is saying for all the rows where sales equals 0, let's count the number of rows per each weekday. So we have 1,236 zero sales days on Sunday. So it seems that Sunday are not open. Yeah. And then the next question, is it because of state holiday? If you look at these two tables. So this gives you the distribution of all the levels of the state holiday. For example, if there are 1,000 and more rows with state holiday equals 0, meaning it's not a state holiday. And then this one gives you the average sales per each level. As you can see, if the state holiday equals B or C, the average is 0. Okay. You can also do a formal test here, like yeah, in a more logically correct manner. The next question is it because of school holiday? Can do the same. Yeah. So all these weekdays, holidays, don't give you a one-to-one correlation. And basically, I checked the variables one by one, and I found the variable called open. So I check if open equals 0, then sales equals 0. If 0 equals 0, open equals 0. So I checked both direction, and then it seems to be a one-to-one perfect correlation. So open is the indicator of whether sales equals 0 or not. The next question is, does the test dataset contain open? The answer is yes. So we have this plan. Okay, plan A. Build a model using open equals 1 only. And then leave open equals 0 and model. When making prediction, we just apply the model for the open days. And for non-open days, sales is 0. So plan 2, include open as a factor to be allowed in our model. So my second question is whether pass 2 is correct. The answer is incorrect, because this is deterministic. I mean, this can be a sales equals 0 can be determined for sure if open equals 0. We don't have to model it. It just as unnecessary variability. Yeah. So go to path 1 instead of path 2. Okay. So that's what we have done here. So we cap out open equals 0. Before that, we check the dimension of the data set. It has a 1,684 rows. And if we carve out open equals 0, leaving only open equals 1, we have this number of rows, like 1,500 rows less. Okay. And then we can look at response and a variable together. This is what we call one-ways. Okay, let's go back to the one-way function in case you guys don't understand. Okay. So basically, it's first doing a summary. Yeah. So basically, it's doing a summary. Okay. So .NA is returning the number of rows per each column, and then in get response is returning the mean of the response per each level of the variable, and then just to change the name of the data set, and then okay. So the scale factor is something you need to do if you want to add the second y-axis. It's a limitation of GGW2. Sorry, ggplot2, but it can be bypassed. Okay, by this code. Okay, and then this function is the ggplot function. So data equals this data set we prepared, and then this is that. It's drawing the variable distribution. Like get column means get this column, like returning. Okay, this function is returning the number of rows per each level of the column, and then this one is returning the average of the response per each level of the column. Okay. Yeah. Let's go back to one way. Okay. I think it's more intuitive if we just look at the graph. Right? The first factor is the store, and if you look at the one way, looks like this. Okay. So bars are the ways or exposure or number of rows. Like for example, there are like slightly more than 600 number of rows. That is about store 1004, and so on and so forth. The lines are average response. For example, the average sales for store 104 is about 300. Yeah. So the ways are different, and the response relativities are different as well. So these are the relativities. These are the ways. Okay. So generally, we should put more trust on more data. Well, this is not a very good example because they are, I would say, fairly evenly distributed. But if this bar is very, very small, then we should probably don't trust this relatively too much. Okay. The second factor is data week. The one way looks like this. Take a while. Okay. So it seems that Monday has the highest revenue and then Sunday is closed. Oh, where's Sunday? Yeah, it's closed. 1, 2, 3, 4, 5, 6, 7 is missing here. 7 is closed. Yeah, but be careful because some packages, like if data week equals 1, some packages actually means the Sunday is the Monday. So read the documentation and also ask your manager. Yeah. And the third one is date. Okay, this will take a while. This is very, very big. Has many, many levels. So normally, if one variable has a lot of levels, we want to group them or band them into groups. Okay. 1, not coming. Okay, anyway, let's move on. Oh yeah, now we have it. So these are the dates. And these slides are the relativities. You can see it's very, very messy. And you can't just put this variable into the model because it's too many levels. Will definitely give you overfitting. Yeah. So what we need to do is to group them into, bind them into groups. Yeah. We use lubricate for date time manipulation. Let's check. So the original column, date column, looks like this. Year, 4 digits, month, 2 digits, date, 2 digits. So it's actually YMD. And YMD is a function and the lubricate is used to pass string to a datetime object. Okay. So by running this line, you're telling R that I want to treat this column as datetime instead of string. Okay. After passing these dates, we can extract a month, a quarter, a year, etc., etc. Yeah. And look at one way. It's passing the days. Yes. I guess it's because of package incompatibility. Okay, let's go to the lubricate. Let's cancel this process. Cancel it. Sorry guys, I have to. Let's create RStudio. And then reopen RStudio. Okay. Share my screen. Share this screen. Okay. A lot of them. Because the memory is clean. Okay. Oh, I'm plotting the huge graph again. should skip this step. Okay. Okay. Let's pause the datetime again. And train sub. Yes, I think it works. Okay, let's try this. What we need to do? Yeah, the Library Day package sometimes can be very glitchy. If this happens, my suggestion is go to the package and then detach the package and then load package again, and then run the parsing code again, and then it works fine. Yeah. Then if we check the one ways, so this is one way with respect to month. So it seems that December has a higher sales. And then if we look at a quarter, yeah. So the fourth quarter is very high. The year, I think it's in line with inflation, I guess, except maybe these two levels too close. Okay, it's a question. So what is the difference between season and quarter? Yeah, sometimes we tend to define our own season instead of using just a quarter, like because for example, quarter, for quarter we just assume what December, January, February, and March to be season quarter one. But if you want to define season, we can combine different months together. For example, December, January, and February. Yeah, sometimes it makes more sense to use the season. For example, if you are modeling for bushfire, yeah, which is highly correlated to season. Okay, next one is customers. This one is very, I don't like this variable. To be honest, I don't like this variable because first of all, it has a very long tail here, and then I look at the relativities, it's increasing and then dropping and then increasing again. So yeah, you can roughly cut it into pieces. For example, okay, this one is including 0 bar. Oh, forgot about it. Okay. So this one is excluding 0 bar. Because I have already removed 0. Oh, okay. And okay, the first part from 0 to 1000 seems to be monotonic increasing. And then the second part from 1000 to 1400 goes sideways, even slightly dropping. Okay. The final part is monotonic increasing. Yeah. And for this variable, because this variable has a lot of levels, and it has a very long tail, normally we don't just model it by treating it as a numeric variable. We tend to band the variable into levels, into several groups. For example, we can try quantiles. So if you compare this graph with, okay, I'll actually compare with this graph, actually. Yeah, if you compare these two graphs, I guess this one gives you a clearer pattern, like increasing, but still we have this drop here. So yeah, if you see something like this in practice, there's two things you need to check. The first one is there error, and secondly, it could be related to some other variables. Like this job is determined by some other variables, not this one, not this custom variable. So you should test the interactions. Okay. And the next one is open. Because we have already subset the data set further by keeping only open equals 1. So so it should be 1 here. Okay. Next one is promo. It makes sense, right? Promotion increases sales. Yeah. Next one, say holiday. Okay, this one is very interesting because we have only one observation that is I. I mean, only one row where state holiday equals A. Although it's a very big difference between these two levels, but I don't think it's a good practice to include this variable in your model because it will lead to overfitting. Yeah. Next one is school holiday. Makes sense, right? Oh, actually, it doesn't make sense. Right. If it's a school holiday, then we actually have more sales. Yeah, probably makes sense. Yeah. And then store type. Yeah, A, C, D. Yeah. Assortment. Okay. Competition distance. This one doesn't look nice because we just use a small subset of the entire data set. If we look at the entire data set, the one-way graph looks like this. It's weird as well, but at least it has some distribution, meaningful distribution. Yeah. And then competition open since month. Okay, looks like this. Just to cover it very quickly because it's just a process to understand the data set, really, like to get a feeling about which factor is the most significant factor. Okay, I got a question here. So this variable is categorical. If we look at the data set, train sub, that's the column. Yeah. And we have the string NA. Remember we did a fix to this variable, right? Table string sub and then sub competition since month. Okay, so November, May, September, and NA missing. Yeah. Okay. So if this variable was missing, we set it to string NA because we want to treat this variable as a categorical variable. But if, for example, train sub customers. If we have NA values in this numeric variable, then we should do something else. So because if we assign string array to the missing values to for a numerical variable, that will change the data type. I mean the type of the column. If we want to make sure that the type of the column stays as numeric, we can try to assign the missing values to some numeric code, for example, -1. I mean, we can't have negative number of customers, so we can use -1. It's numeric, and it gives you a clear indication that this variable is missing. Yeah. Okay, next one is competition open since it's very similar, and then promote to. Okay, this one is a little bit counterintuitive because we are offering some promotion, but we have fewer sales, less sales. So yeah. So again, this could be error or some correlation interaction. Yeah. Next one, promo to since week. Very similar. Don't cover it in too much details. Okay. So in practice, as you can see, we can combine the variable distribution check and the one-way check together, because the one-way check is a combination of variable distribution and the average response for each level of the variable. So we can potentially just use one-way check instead of separate variable distribution and one-way check. Then we finally have the chance to build a model. We'll take GLM as an example. So in this demo code, I use H2O machine learning platform. So H2O is Java-based machine learning platform. Is written based on JDK version 13, and JDK is short for Java Developer Kit. So if you have not already installed H2O, then you can run this code to install H2O from scratch. Okay, to activate, to start H2O, you need to open your terminal. Okay. So this is share my screen. How can I stop sharing, share screen, and then terminal? Okay, can you guys see my terminal? Okay. So, well, if you're using Mac, MacBook Air or MacBook Pro, you should open your terminal. But if you are using Windows operating system, you should open your command prompt. Yeah, basically the same thing. Yeah, and you should copy this line to your terminal. Basically, this tells your terminal to go to a certain folder where the H2O function, H2O program is located. Okay, CD means change of directory. And then you run this code. Basically, it tells your terminal that you are using Java, and then you want to open this Java program. Okay, so this file is located inside this folder. Okay, and then you run this. So this code is to initialize H2O, and n thread equals -1, meaning that you're using all the CPUs. Okay, I'm not sure how many CPUs you have. If you are using your computer, your office computer, normally it has very good specs. You should have at least 8 CPUs. Yeah, by setting -1, you are using all of your CPUs. Okay. Then I need to touch a little bit on the idea of cross-validation. So this is an example of 5-fold cross-validation. Let's assume this is your entire data set, and then you carve out 20% of your data set as your tested data set, and then the 80% as your model training data set. And because you're using five-fold cross-validation, so basically doing 5 iterations. For iteration 1, you're using this part, this 20% of the 80% as the validation data set, and then the second iteration you're using this this part as the validation data set, and then third one, fourth one, fifth one. Okay. So the reason why you need to do this 5-fold on the 80% training data set is to make sure that your model is robust no matter how you split your data set. Once you're happy after this 5-fold cross-validation, you can finalize your model and then test your model on this 20% training data set. Okay, but for this demo, we'll skip the cross-validation part because it's really, really time-consuming. Okay. And also factor selecting. In practice, we should consider, for example, external input, like if there's a reference model already, or maybe we can just run a quick GBM by using all the factors inside this model, inside this data set, and then output the importance matrix, I mean the gain matrix, and pick the most significant factors. Or we can randomly include or exclude certain variables. Depends a little bit on luck. Or maybe the product team asks you to include certain factors. Okay. Okay, in this example, we just use these factors.
Excuse me, sorry to interrupt. Robert, could you share the RStudio window? I think
sorry.
Yeah.
Sorry, my bad. Okay. Okay, maybe you guys didn't. Sorry.
Right,
Okay.
you just maybe repeat the earlier stuff.
Okay, like the 5-fold, right?
Yeah,
okay.
5 days ago. Yeah, thank you.
Okay. So sorry, my bad. Okay. So the 20% is carved out as your tested data set, and you don't touch it when you train your model. And then you use the 80% to train your model, and then you apply the 5-fold. In the first round, you use this 20% of your 80% training data set as your validation data set, and then the second round, this part as the validation data set, and the third round, fourth round, fifth round. And then by doing this 5-fold, you can make sure that your model trained from this 80% data set is robust, no matter how you split your data set into training and validation. Does that make sense? Okay. And then if you're happy with the model, you can finalize the model and then test your model performance on the tested data set. Yeah. Okay. In this example, we just pick the following factors instead of doing this 3 steps, because it's just a demo. Okay. So the factors are store, day of week, month, year, custom band, sort type, assortment, combination distance, promo interval. Okay, so HTML only accepts 2 types of inputs, numeric and integer. So if we have a categorical variable, we should change it to integer. But we can't use as integer. As integer, some categorical variable. This is not good practice because you lose the level names. Instead, we use a factor. So you put some categorical variables here, and then you specify the levels by this parameter. And this column, after applying this factor, is saved as integer, but it still has the level names. Okay. So first of all, let's check the data type. You can use type of function to check the data type for each column of the data set. Okay. So we have character, integer, character, integer, character. Okay. So as I said, we need to change character string to a factor integer. Okay. So overriding this factor, no, sorry, overriding this variable by applying factor function. Yeah. And although this variable, day of week is integer, oh, we don't have to do this. Sorry. But we can run it anyway. Yeah. It's already an integer. Yeah. Then let's check the types again. So all integer, all good. If we haven't banned customers into custom ban and just use customers, this one is numeric. But numeric is okay. Yeah. Okay, because all the variables are integers, factors, we're happy, and we move on to the H2O platform for machine learning. Okay. So the first step is to change the data.table to a hex file. Hex file is a sort of object format accepted by H2O for very efficient machine learning calculation, manipulations. Yeah. So if we we check the type of the original data set. This says it's a list. Okay. And if we check if it's a data.table, that's true. We check the type of train underscore H2O, it says environment. It's a weird name, but it's the name for the hex format. We check whether it's a H2O format, it says true. Okay. We can check the levels again. Check the dimension. It has 7,000 rows. Rows are unchanged. So we didn't skip or drop any rows by accident. Okay. And then sometimes you want to set your base level. You can use this function to set your base level. I will explain this later. Okay. Then we move on to model training. Okay. So we're keeping the intercept. And then we give some name to the model. And our X is the selected factors here. 9 factors here. And then our response is sales. Now training data set is train underscore H2O. We don't have a validation frame because we're not doing cross validation. And we assume the distribution is gamma. And then alpha, lambda set is for regularization. Okay, I don't want to talk about regularization here because it's a huge topic. But what I want to say is that this function is actually a combination of GLM and GLM-net. These two functions. GLM-net is a normal GLM with some regularization, basically some penalties on the complexity of the model. If we set lambda equals 0, then we're telling H2O to do just a ordinary GLM, not GLM-net, no regularization. Okay. And then we have this very nice function save model. Save model is a function to save the model into a zip file. It saves the space a lot. Okay. So let's train the model. Complete. After we have the model, we need to do some evaluation. The first thing we need to evaluate is how accurate our model is. Let's say AVE. AVE stands for actual versus expected. Okay. So let's do a prediction on the same training data set. Okay. Look at the graph. It's very, very bad, actually. Okay, so let's see. The right one is the actual, and then the green one is the smooth actual. Basically, can say that if we just feed the model using actual only, we possibly will feed a curve like this. And then this is our prediction. See, it over predicts on the left tail, and then over predicts on the right tail. And then this part we have a strange hump here, and underfitting here. For this part, it's okay. Yeah. This is very bad, but I think it's expected because we didn't do much factor selection. We didn't do cross validation. It's just a demonstration. It's just for illustration. Yeah. Okay. Histograms. Again, it's very bad. Let me show you. So the actual looks like this. So it looks like a gamma distribution, 1 peak. Our fitted has 2 peaks, meaning that our model are missing some important factors. Yeah, again, it's related with our factor selection. Okay, let's look at other metrics. Okay, so basically, if you type the model ID, model underscore GLM, it gives you the model, the intercept, and MSE mean square error, root mean square error, and mean average error. And I'm not sure about this one. So all these accuracy measures. Okay. Next, we need to explain our results. Well, GLM is easy. You just look at the coefficients. For training methods, I mean GBM, random forest, you have to do some very, basically there are 2 ways to look at GBM. You can either look at the gain matrix, or you can use SHAP method. SHAP method is the state-of-art method. Basically, it's using some subrogate model to represent your model, and the subrogate model has better explainability, and basically it's visualizing the impact of each individual factor. Okay. So, okay. This is the coefficients of all the variables selected. Yeah. As you can see, I think you should look at both size and direction. I mean, this is the most positive, or the coefficients with the highest value. Sorry, the variable with the highest coefficient, and this is the variable with the lowest coefficient. These 2 are both significant. You can kind of have a sense of significance by looking at the length of the bar, not the direction of the bar. But if you look at here, month 2 and combination distance, these 2 are very, very insignificant. Yeah. Okay. So we have run over the code. There are some other things I want to comment. The first thing is that modeling is an iterative process, and the control cycle comes into play here. Okay, make it bigger. So apparently we're not happy with your model by looking at the histogram and the AVE, and we can make some changes to improve the performance of the model. For example, including, excluding variables. Like for example, we can detrend, because it's a time theory, right? Time theory has trends, cycles, seasonalities, and random noise. Yeah, if you can isolate each component and model separately, that could potentially improve the performance of your model, but it's very time consuming, and also you need to have large quantity of high quality data. Yeah. Okay. The second one is we can test interaction. You remember the strange harm? Sorry. Come on. Okay, it's very slow. Okay. Okay, you remember here, string harm here, and also the second peak here, right? These are the indicators of the fact that we are missing some important factors. Okay. And then we can try regularization. I encourage you guys to Google ridge regression, loss regression, elastic regression yourself. But the basic idea is that normal GLM is minimizing the GLM loss function, but GLM with regularization is minimizing GLM loss function plus lambda times some regularization. By including this piece, we can control the size of the coefficients. And if the size of the coefficients becomes very, very small, the algorithm assign it to 0. So by doing this, we can actually control the complexity of the model. I mean, if the coefficient is 0, we're not actually using the variable. Okay, you can have a look at this. Google yourself. You can also try other methods like GBM. You can use XGBoost, H2O like GBM. These are the recommended packages. And then after model building and model iteration, we can apply the model. And okay, the first step, we can do the same data prep for the tested data set for all the feature engineering, like banding, categorical stuff, numerical stuff, yeah. And then make prediction for non-zero sales, okay. But for zero sales, we don't do the model. If open equals 0, meaning that the store is closed, sale is 0. Okay, and then we can output the results into the format specified in the sample submission .scv, which I think Danny has already covered that. And then we can upload the result to Kaggle, and Kaggle will give you a score. Okay, that's it. Good luck. Questions will be answered in the Q&A session.